In this video, I'll show you how you can build your very own remote-controlled robotics platform just like this for whatever purpose you like, whether it's for fun, for research, or even for combat robotics. Let's get started. Welcome back to Maker's Muse. My name is Angus, and if you're new to the channel, then welcome. It's my aim here to empower your creativity through technology, just like this. This is my off-road robotics platform that I recently showed on the channel that a lot of you really liked, and in that video I promised to show you a breakdown of how you can build your own. This is actually kind of just a introductory video into robotics platforms in general, what you need to get, how they work, and how you can use them to make all manner of different interesting projects, because at the heart of it, they're all kind of the same. It's just the implementation will change depending on what you're going for. And in this project, the aim was simple: get some wacky wobbly wheels and make a platform that I could use to test them out. So I wanted to make a four-wheel drive platform that I could control remotely and then drive around and see how the wheels responded on different surfaces. So we'll be starting with the electronics, and then I'll show you the design process and then the assembly process to put something like this together. And let me just say, there's a lot involved. This is sort of an introductory video. There's a lot that you'll need to do some research independently from this video. It's not just a click a list of purchase links and then throw it all together and magically it works. It's kind of involved, but I will say that it's very rewarding. I learned so much building combat robotics back in high school that it influenced my university, and then my 3D printing interest, which is kind of where I am today, is thanks to my interest in combat robotics. So there's a lot involved, but it's definitely worthwhile checking out. So the component we'll start with is the gear motor. This is what you'll use to make your platform able to move around. And essentially it's a motor with a geared reduction to an output shaft that you attach your wheel or whatever to, so the machine can move. And if you just go on like eBay and search gear motor, you'll see just how daunting this task can be. There is thousands of different motors to choose from, all different price points and features, and it can be a bit daunting to know what to look for. So let me break it down for you. A general good range for a robot platform I've found, at least of this size, is around 200 RPM up to maybe 800 to perhaps 1,000, which is going to be a very fast remote control platform. But 200 is probably the minimum speed I'd go for. Any lower, it's going to be very sluggish. It might have high torque due to the high reduction, but it's going to be very slow. So I'd say 200 up to maybe 800 is a good RPM range for your first robotics platform. So what I'll generally do is just search for like 500 RPM gear motor on eBay, for example, and I'll have a look and see what shows up. And you'll find listings like this. So DC 12 volt motor gear reduction, worm, there is no worm reduction, no worm gear in this motor, but whatever. 60 to 500. So they've actually got different RPM output ranges available, which is the different gear reductions. So again, 60, 100, 200, 60 would be like 1 revolution a second. That's so slow. Whereas you can go all the way out to 3 to 500. So let's say you want to do 500, quite a fast platform at 12 volts. And here we can see the sizing for the motor. It's got 52, which is about that in length, 24.4, which is just about an inch in diameter. And that's a decent size for a platform like this. You could probably drive with 4 of these, something that's about 3 kilos in weight or so, without too much trouble. But if you want to copy exactly what I've built, I did buy these surplus motors. And these are 184 to 500 RPM, again, depending on voltage. But the reason I chose these is because they had a nice looking planetary gearbox. So planetary gears are a lot more durable than a spur gear reduction. It's not really going to be a problem if you're not abusing your platform, but if you want to build like a combat robotics platform, then you might want to choose planetary gears instead. I will say though, with this gear motor, the motor itself seems a bit gutless. It's all a bit trial and error depending on what you go for, and that's just how much current the motor pulls in. Some motors are quite efficient, but therefore they don't put out too much torque. But that takes us to the next section, and that's what speed controller you need to select now based on the motor choice that you've got. Okay, so to interface with your gear motor, you need something called an ESC, or electronic speed controller, and this will control the speed by varying how much power is given to the motor based on your inputs from the battery. It's not like, you're just putting a motor straight on the terminals of the battery, it's going to be full power. This lets you vary speed and also change directions, which is very important for trying to control something precisely. For my off-road platform, I use 2 BotBits 30 amp brushed speed controllers. They're very much overkill for the size of this platform, but I had them on hand. They also have the 10 amp controls, But you might be wondering, what does this amperage rating even mean? Well, that's how much current the speed controller can handle before it kind of overheats and eventually releases the magic smoke and breaks. They get hot during operation, and if you run them too hard, they will break. But if you have them spec'd above what you need, then it's like bulletproof, they'll last forever. So I went overkill here, but how do you know what sort of current rating you should be going for anyway? If we go back to your motors, if we go down the page, sometimes the seller will have your stall current and load current. So when these motors are under load, they've got a torque rating here, and they've got a load current of 145 milliamps, which is tiny, really tiny. But what you got to worry about is the stall torque. That is like locking the motor and then running it. And that stall torque is usually what blows up the controllers. So 2.1 amps, which is very, very small still compared to the 30 amp rating of these controllers. But there is very, very weak ESCs on the market that might not even handle that. There's tons that you can choose from. The bot bits are just single output, which you can chain to 2 motors if you like on one side. Or there's the Sabertooth, which is a dual 5 amp motor driver, so you can have it controlling both sides from just one unit. It's got 2 separate outputs for each side. Or you can also get speed controllers that are big enough to power a go-kart sized platform like this Robotech, which is a dual channel 150 amp brushed DC motor controller, which can handle up to 60 volts. Obviously massive and massively expensive, but it's pretty cool. You can make something like this that's the size of a golf cart, and you still would be able to remote control it if you have the suitable hardware. Alright, now is battery. It's determined on what gear motors you want and what speed controller you've chosen to determine what battery you should go for. I generally use lithium polymer batteries because they're very cheap, they're lightweight, and they're used in a lot of remote control projects anyway, so they just fit right into the ecosystem. So a few things to note about lithium polymer, starting with the safety. They are dangerous. If they are punctured or shorted or overcharged, they can burst into flames. You want to make sure that these are stored in a non-flammable area, like a cake tin or something, in a safe space. And when you're charging them, they need to be charged on a non-flammable surface like a tile or something like that, and under observation at all times. Beyond that though, if you treat them well, they're actually very, very safe. You have to really abuse them to make them catch fire. So how do you choose a battery for your project? Well, you have to consider the voltage, you have to consider the capacity, and you have to consider how much current it can put out, what its discharge rate is. Because some motors will be very current hungry, and you need a battery that will keep up, otherwise it might explode. So for example, this battery is just a very cheap one on Hobby King. This is a Zippy Compact, 1000 milliamp hour, 3 cell, 25C Lipo. So what do those numbers mean? Well, the 3 cell means it's got 3 separate cells in them, and for a lithium battery, that means it's 11.1 volts total, which is very close to the 12 volts of those gear motors, which makes it a suitable battery for that voltage range. Then you have the capacity, 1000 milliamp hour or 1 amp hour. That's how much power it can discharge over a period of time. And then you have the C rating, and that is how fast you can discharge the battery safely. And if you exceed the C rating, that's when things get a bit hairy and you can blow up packs, or they can get puffy and that sort of thing. And they won't last very long, or they might catch fire. And you can figure out the discharge current by timesing the C rating, which is 25C, times the amp hour rating, which here it's 1000 milliamp, which is 1 amp hour. And that means you can discharge this battery at 25 amps continuously till it needs to be recharged, which is way higher than this little platform will ever do. Because remember, those motors were like 2.1 amps stalled, so they have to be all stalled, and still it would be like under 9 amps. So very safely, this battery can handle the current of this platform. And in terms of your capacity, you want to determine how long the platform will run for. 1000 milliamp hour is quite small, but for something this small with very low current draw, it still lasts for a very long time, at least 20 minutes. And if you want to double the capacity, you get double the runtime, etc. And you can get humongous lithium polymer batteries if you want to run something all day, if you like. It's absolutely possible. And obviously, the larger capacity you get with the same C rating, the higher current discharge you can pull out of it because of how that equation works. Lithium polymer batteries also can't be discharged to completely flat because that will destroy them and they won't recharge properly. So I don't recommend driving these until your robot can't move anymore. If you see it start getting a little bit sluggish, then I would change packs and recharge. There is some speed controllers will have a low voltage cutoff to protect your battery. I generally don't bother with that, but you can definitely get that if that's your kind of thing. And then you'll need to recharge the lithium polymer batteries, and you don't need to spend a lot of money doing it if you're using a small pack like this, up to 4 cells. You can use something like this, which I highly recommend. It's just a slow charger that uses the balance leads because it keeps remember this is 3 cell, keeps each cell balanced, which again is important for longevity. This is a really cheap charger that just uses a 12 volt DC jack. Your 3D printer probably has one already. And I just plug the battery in, let it sit there, and then it will charge slowly, and then it beeps at me when it's done. You can get very expensive, much more advanced lithium polymer battery chargers, which can charge much faster, or if you have a much larger pack, probably more important, but for this sort of little thing, one of these little chargers is absolutely more than adequate. Okay, so we have our platform with its gear motors, we've got the speed controller, and we've got the battery. Now we need to tell the whole thing what to do. And this is where the remote control side comes in. So again, this platform is remote controlled. I'm not talking about building autonomous robots in this video, but you absolutely could get some sort of autonomous system and slap it in at this stage. But this platform is remote controlled, so I'm going to talk about remote controls you should check out. So there is so many different remote control systems out there. What I do recommend is a transmitter like this, which is a multi-protocol transmitter. So that means it can communicate with receivers that are from different brands quite easily by just changing the protocol. You're not locked into a certain brand and protocol of transmitter and receiver. And these are pretty cheap. They're on Banggood. I'll have a link to all the stuff in the description below. The only thing I don't like is they're a bit kiddie, like a bit small. When we're talking about remote control transmitters, you need to think about how many channels you get and the form factor, and if you can do onboard mixing, and if that's important to you. So for example, with these, this one has up to 12. You'll need a receiver that can receive 12 channels. But for example, how it works is you got 1, 2 on one stick, and then 1, 2 on the other stick. Then you got all these little auxiliary like switches and dials for some sort of proportional or on-off control, which is transmitted to your receiver on your platform. And then you want to do something called mixing. And mixing is important because this platform's like a tank. Each side is its own channel, and we don't want to control it by, one up and down is just one side moving, and then left and right is just the other side moving. We want to make up and down have both sides go forwards, and then left and right actually reverses them so it can spin on the spot like a tank. And that's called V-tail mixing or tank mixing, that sort of thing. There's heaps of tutorials on different platforms on how to do it. You can do it on this transmitter, so I can recommend it, but you can also buy something called a V-tail mixer, which you can plug in between the receiver and your speed controllers to do it on board at a hardware level. So you have a remote control that's more like one of the remote control car ones, which might only have 2 channels. You can still use that using a hardware V-tail mixer by putting that in the robot platform itself. I just recommend these because it gives you so much more flexibility, and you can add things like a servo arm or lights or activate like a camera or all sorts of things. And they're very cheap these days. They're much more affordable than when I first got into combat robotics, that's for sure. In terms of the receiver, again, if you get like a multi-protocol remote control transmitter, then you have heaps of options. Just look at what protocols it supports. But this is like a great one that I know does work with the transmitter I've shown. And you get 6 channels of control here. So that's more than enough for most robotics platforms, I could imagine. You need only 2 for the control of the drive system. So something like this is great. They're very cheap, and I will grab a couple because they're pretty fragile, and I often just put them in the remote control builds I do and then just leave them in there. And they join together through a system called binding. So look at the manual for your transmitter to see how binding works. It's generally a plug you put in, and then you turn it on. You can see it actually in the photo here. You put it into one of the channels, turn it on, it'll flash, and then you press a button on your transmitter, and it binds together. And long gone are the days of having like frequency crystals and stuff. These systems all work on the 2.5 gigahertz frequency range, and they're very reliable. They have great range. It's just so they work so much better than the old-fashioned days of having huge aerials and having to be like within meters of your platform. There's also a lot of MISC stuff that goes into these platforms. One of them you'll need to get is the plugs. These are XT60s. If you have an Ender 3, you'll probably be quite familiar with them. And there's heaps of different variations now. You can get XT30s for like smaller platforms. They'd probably be totally fine or something like this. Or XT90s, which are much larger for much bigger high current applications. And there's also different like mounting options. For example, you've got like a mounting hole on this one. So if you want to mount it to the frame, you could. So it would lock in place. Then you probably need lots of wire. I recommend this sort of wet noodle stuff. It's quite nice, it's flexible. Not as durable to abrasion, I suppose, but much easier to route in a system. Then you'll also need some sort of switch. Just choose a switch that can handle the current of your system at the voltage that you've used. It's all fairly basic. You'll be able to get it as you go along, and you can adjust it and adapt it for whatever platform you're building. This is something called a removable link. You don't really need it for something like this, but if you're doing a dangerous platform, I recommend it. This is like a secondary switch where if something goes out of control, you have it accessible and you just yank it and it breaks the circuit. So it's like a switch, but it's like an emergency switch you can pull out to just stop all power, which I do recommend for platforms that are large enough to cause any sort of damage. Like if this little thing drives into me, it hurts a little bit, but it's not a big deal. If you have something that weighs 20 kilos and it chugs into your leg, you might break an ankle. So you might want something like this to stop an out of control system if something does go awry. I do also recommend having some kind of light to show that the platform is on and live. I just used some LEDs on the front of this one, and they've got a resistor light, soldered in, and they go straight into the battery through the switch as well. So again, it's only 11.1 volts. You can drop that down quite safely with a resistor, just to show the whole platform's on. I often will do that to make sure that you can see everything's on and live, and you know when it's safe and when it's you got to be careful with it. Alrighty, so I'm going to take this opportunity to go through my CAD design for the wobbly wheel robot platform. That you can find the links also in the description below to print out yourself and use it for whatever purpose you like. You can use it for just a remote control platform. You can add your own autonomous system to piggyback the speed controllers and control it autonomously. You can add sensors, cameras, whatever you like. I'm just going to go through the design process just quickly to show you what my sort of thought process was. So what I did is I designed it with the motor pods that snap into place. And I did that because the gear motors that you find and select will probably be different to what I used, because I use surplus units as I showed you, and it's very difficult to find motors sometimes. So they actually snap into the frame here and use these little locking points to snap in. And in those files I've included a blank version of this motor mount, so there's no cutout in the middle for the actual motor. So whatever you choose, for example, if it's like 24 millimeters in diameter, you can punch a 24 millimeter hole through this motor mount and it will suit your motor. This design also has a lot of allocation for reinforcing. So if the snapping points aren't durable enough for your application, you can also put a nut in, just a M5 nut. And then what you can do is just run an M5 bolt into that nut, just a little stubby one, and it will give it a little bit more purchase and reinforcing. And depending on your clearances, the motor mounts are quite tight anyway, but you can also put a nut and bolt through to clamp them down just a bit so the motors don't move at all during operation. All of the parts print really easily except the main body, and I do apologize, it's got a lot of complicated detail to it that just had to be there for the thing to work, which means it does need support material. And this is how I generally do it. This is like 15 degrees overhang. Yeah, so 15 degrees overhang support material automatically generated. You could manipulate this. So for example, it's not necessarily needed in the holes that are horizontal, but it is needed for the overhangs for the motor mount that clamps into place, and it is needed for how the top cover bolts into place. There's a little underside recess for a nut, and the nut goes in there, and then it presses in, and the top cover is secured with an M5 screw. These details aren't necessarily required if you aren't designing something that has to bolt together and be securely contained. So I've also included the original Fusion 360 model and the step file if you want to change these details, such as just remove them or add a column so there's no support material necessary. But I just like it because it gives you a lot of internal space. So as you can see, wires take up a huge amount of space in these platforms when you're attaching everything, joining it all together. It gives you a lot of wiggle room by having it overhang like that. But if you want to modify it, you totally can, and the files allow you to do that. Alright, so all your parts have arrived, you're excited, you've made your frame, you're ready to put it all together. Now you have to wire it up. This is, and I'm going to give you a warning here, the most tedious, difficult part of the whole process. If you get it wrong, you can blow everything up. If you get it right, it's really, really exhilarating. And there's going to be probably a little bit of troubleshooting along the way, but just take your time with it and you'll not have any issues. So how do you wire up a platform like this? Well, it looks like a nest of spaghetti, but it's actually quite simple in theory. The battery goes into your speed controllers, then your speed controllers output to your motors, and your receiver connects to your speed controllers, and your receiver will tell them what to do. You also have a switch, probably, hopefully, in line to turn things on and off, and then a light so you know when the whole platform's on and off. That's it. But in practice, to make it all join together is a little bit more challenging. So here's a wiring diagram I threw together on how this platform works. The most difficult part I find is splitting the battery, because each controller, at least in this case, I've got the two bot bits 30 amp controllers, has its own power in. So you need to get the battery and then split it into two. And it generally looks like something like this. So it's not very neat, but the battery goes in here, and then it splits the wires into two, and then one speed controller, the other speed controller, like that. And then I have a switch which interrupts the positive side in this case, going back to the battery. It doesn't matter if it's on positive or negative, as long as it interrupts that flow, so you can turn the whole system off or on safely. You will need to do some soldering to put this whole thing together. Even if you buy parts with plugs attached, you'll still need to attach the switch and that. And soldering is a critical maker skill. So if you haven't done it already, then you need to check it out. For something like this, I recommend a 40 watt or higher soldering iron. Anything lower, you can't get the heat into these components, because again, they're designed for high current draw generally, which means they have a lot of metal to heat up, and it dissipates the heat very quickly. So you need a higher power soldering iron instead of just sitting there with a low power one that just won't get to temperature, won't melt the solder, and actually will do more damage overall than something that's hotter, quicker. Throughout this whole process, you need to be really careful of polarity. So that is your positive and negative terminal on your battery. The red is positive and the black is negative. You need to make sure this is plugged correctly into your speed controller. That is, the positive goes to positive and negative goes to negative. Otherwise, you will blow up your speed controller. This only applies to the input. The output of the speed controller that goes to the motors, you don't have to worry about polarity. It just determines which direction the motor will spin, in which direction you push the stick. So if the motor is turning the direction that you don't want, for example, if you push the stick forwards and the robot side goes backwards, just reverse the output wires on that side of the speed controller. But I can't say it enough, get your polarity right from the battery into the speed controllers, otherwise things will go boom. Your speed controllers plug into the receiver using a 3-pin plug. It has ground, positive, and then a data pin, which is either going to be white or maybe orange. And just consult the manual for which alignment that is. Sometimes ground's facing outwards, sometimes it's facing inwards. They're all different, just consult that. Then you need to figure out what channel on the transmitter affects what on the receiver, and sometimes it's not very intuitive. Consult the manual, but often I'll just do trial and error here. I'll plug the plug in to maybe 1 and 2, turn the system on when it's like off the ground and the motors can't touch anything, and see what channel on the transmitter moves what, and then trial and error until I get the plugs in the right spot. And then once you're happy with that, make sure there's no exposed contacts, make sure there's no things that will jam into the battery when you put the top cover down, make sure it's all safe, the battery's charged, your transmitter's charged, and then go have fun, because you have earned it. It is a huge undertaking to build something like this, so well done. If you get something like this moving, it's a huge accomplishment. It's not something that many people can do, so you deserve massive praise. So I hope this video has given you a good primer into building remote-controlled platforms. It's a lot to take in. Yes, you're going to spend a lot of time doing additional researching, but I find it just so rewarding, because once you have these parts, yeah, they are fairly large investment, not as much as they used to be, but it is a fairly high cost endeavor to get started. You can use them again and again and again in different things. For example, this. This is a remote controlled bi-cylinder that has inside it this little mechanism I did that has counterweights that swing around. The whole thing can move around in a weird way. I did a video on it ages ago. You can check it out here. This uses the same stuff. It uses little remote controlled gear motors with the electronic speed controllers and a tiny lithium polymer battery. It's exactly the same concept, just a different implementation. And if you want more like remote control weird stuff content and remote control combat robotics content, then there's one of my fellow Aussies, Ben from Team Panic. He's been doing ant weights using 3D printing and stuff like this for years, and he uploads content really regularly, and he has heaps of tutorials on how to do it, so I'm going to link to him here as well. So if you want to get a bigger fix on crazy little remote control platforms like this, definitely go check his platform out. Either way, guys, I hope you found this video useful and look forward to seeing you again very shortly here on Maker's Muse. Catch you later, guys. Bye.